The most immediate fear surrounding artificial intelligence in the classroom is that it functions as a shortcut for assignments, creating students more dependent on software than their own intellect. To understand why educators are concerned, we have to look at the biology of deep learning. Learning requires what researchers call productive struggle. This is the deliberate effort of figuring out information that isn't immediately obvious, the mental friction that actually builds and solidifies a memory. When a student uses AI to generate an answer instantly, they bypass that internal pathway. The friction drops to zero, and the cognitive connection withers from a lack of use. The technology itself isn't the threat. The problem is dropping a friction-eliminating machine into an education system designed around fixed outputs. It short-circuits the biological way the human brain learns. Within our current classroom structures, the first casualty is critical thinking. Relying on quick, generated solutions, students lose the opportunity to grapple with complex problems independently. This leads to a homogenization of thought. When individual creative processes are replaced by AI-generated content, unique perspectives are smoothed over into a uniform, average output. There are physical consequences, too. Constant availability of instant assistance can alter the cognitive pathways of a developing adolescent brain, potentially affecting the sense of achievement we associate with independent discovery. The stunted thinking, the flattened creativity, and altered neural pathways are the predictable outcomes when we pair advanced AI with a rigid traditional school model. We can see how setting different boundaries changes this outcome by looking at Professor Gilbert's classroom. She introduces her students to the technology through a specific quick start guide. Her rules allow students to use AI for brainstorming or proofreading, but the bulk of the actual thinking and writing must be done independently. To maintain accountability, students must list the tools they used and justify how the final product still demonstrates the specific skills they've gained in the course. By treating AI as a supportive tool rather than a replacement for work, students build self-efficacy and learn the technology's limitations instead of becoming dependent on it. On a larger scale, this shift moves us towards an AI-driven personalized education model. AI-powered programs can adapt to the unique learning styles of neurodivergent students, offering the specific types of feedback and explanations they need to thrive. This line graph shows the conflict between traditional school hours and an adolescent's biological clock, which naturally shifts to later sleep and wake times. AI's 24/7 accessibility allows these students to learn during their optimal cognitive windows. This flexibility extends to the curriculum itself. Instead of a cookie-cutter degree path, AI career coaches can now hold dynamic dialogues with students to connect their specific skills to varied academic and professional futures. In a system redesigned around this kind of personalization, AI eliminates the traditional sink-or-swim environment, where only a few students can succeed. This matrix shows the choice society faces. On the left, the traditional model offers limited access and delayed feedback, inherently restricted by classroom sizes and resource costs. On the right, the AI-driven model is scalable, offering highly tailored customization. Clinging to a fixed mindset education model while using these tools creates a real risk of making children's own cognitive efforts feel superfluous. Conversely, evolving our systems towards personalized learning allows AI to help students explore subjects beyond the standard curriculum, encouraging the kind of exploration that continues into adulthood. AI is the catalyst, forcing the traditional education system to finally evolve.